We're going to solve Project Euler problem 32. The problem is the following one. We have certain products of this form, and some of these products are pan-digital. Pan-digital means that every digit between 1 and 9 appears exactly one time. So the problem is find the sum of all these products where this identity can be written in a pan-digital way. Alright. So first of all, in order to do that, we'll obviously have to define a function that tells us if a product is pan-digital or not. So I'll call this is pan-digital, and this takes, well, a triple of three numbers that are in our product, the two multiplicants and the product itself, and then returns a Boolean value. So we will implement this the easy way, not the efficient way. So if we have a triple A, B and C, where A times B equals C, then we will just convert this into a string, show A, and concatenate it with show B and with show C. We're going to sort this and then compare it to 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's it. So that's our function to check if a number is pan-digital. Of course, we need to import data.list for the sort function. Alright, now let's generate every product that we need to check. I'm going to call this list of all products, and this is just a list of triples int, and we can generate all products. First of all, we notice that every product has the form A, B and C, and well, let's have a look at C. If every product in here has the form A times B equals C, and this identity right here needs to be pan-digital, then we can know for sure that C can never be greater than 10,000. Because if it were greater than 10,000, it would have 5 digits. That would only leave 5 digits for these two numbers, and if we multiply a 2-digit number and a 3-digit number, we can never reach a 5-digit number. Yeah. So let's, or at least not a pan-digital one, but well, whatever. So we know that we can choose C in the range 1 to 10,000. Now then we need to choose A. Now A can theoretically range from, well, 1 to 10,000 as well, but A times another value B must equal C. So actually A can only run, or we only need to check values that go from 1 to the square root of C. Because if we were to go above the square root of C, then we would actually find duplicate values, where we choose some A that is larger than the square root of C, and would then have to choose B smaller than the square root of C, so that we can reach the final product of C. So let's do this. Square root of C, of course we have to define SQ, which I will do here, where SQ of a number x is equal to the floor of the square root, from integral x. Well, let's write this in the point-free style. So now we have a and c, and then we need b. But b is, if this identity holds and we know a and c, then b is already determined. By the following, we can just write it as let b equal to well, c divided by a. In order for that to work though, we need to check if a actually divides c, because not every a in this range will divide every c in this range, and if it doesn't, then the equation won't hold. So we can check for that in here, if c, by adding the guard, if c modulo a is equal to 0. Alright, so these are all our products that we consider. Now let's write the function pendigital product sum, which will calculate the value we need to submit. Pen product sum. This of course is just an integer, and we will do this as follows. First of all, we will filter these products on their pendigitality. So filter by the predicate is pendigital, and we filter the list of all the products. Now this will give us all the triplets that are pendigital. Then we are only interested in the value of the product, so that is c. So we can just dump values a and b and just store c, the third value, in this tuple. So let's go ahead, just map every triple to its third entry. Now we have all the products that we can reach via pendigital identities, and now the problem statement explicitly has the hint that duplicates only need to be considered once. So we need to remove all duplicates. This can be done with nup. Nup is a function from data.list that removes duplicates, and then we just sum them up. Now for our main function. Oh no, what's that? Okay. We're just going to print the pendigital product sum. Now let's go ahead, compile this. I can't type. And run it with time. And as you see, this gives us the correct answer in 0.06 seconds. Thanks for watching.